Hi guys, welcome to yet another video. This class will be on the master level, at GRE level, GATE level, IIT JAM level. So we are going to start with the basics of classical mechanics. Before I start, I need to introduce you mechanics in different formats. So in order to understand them, we need to understand the basic measurements in physics, which is mass, length, and time, right? And we talk in steps of three types of mechanics. To begin with, it will be classical mechanics. Then we have quantum mechanics. Then we have relativistic mechanics. Sec mechanics. So when I talk about classical mechanics, when we talk about mass, if you go to a vegetable shop vendor, what is the language we use? The language we use is kg, kilogram, kg. That's what we are going to use mass as a unit. Then when we talk about length, we can understand in steps of meters. Yeah, how many meters is your friend sitting next to you? You can do that. And if you talk about time, you can blink of your eye in seconds. So time, you can feel it in seconds. This is the measurement. This is the classical world in which our rules of Newtonian mechanics work. And also I'll be talking about new types of mechanics called Lagrangian mechanics and Hamiltonian mechanics, which we will go in detail, step by step, in detail, so that you can crack your IIT JAM, you can crack your NET exam, you can crack your GRE, and you also can crack your GATE exams. Okay, so when we talk about quantum mechanical world, it's a tiny world, microscopic world. We know that. What is the tiniest mass we can measure? Which is the mass of the electron, which is 9.1 into 10 power minus 31 kilograms. 10 power minus 31, that is 0.00031 zeros. A 91. That's how small we are talking about the mass of an electron to be, right? Then when I talk about length, we can talk in steps of Planck's length, which is approximately 6.626 10 power minus 34 joule second. So 10 power minus 34, which is a very tiny thing which we can't see from our naked eye. Then when we talk about time, we talk with respect to an atomic clock, which is in steps of picoseconds, 10 power minus 12 seconds. Then when we now understanding the tiny world, and this is the world which we live in, and now let us go to the big world, okay, which is called as relativistic mechanics world. So when I talk about mass, we'll be measuring the mass of the sun, which is approximately 2 into 10 power plus 30 kg. So there's a big difference between 10 power minus and 10 power plus. Being a master's student or an undergrad student, you should know when 10 power minus something is small and 10 power plus something is a huge number. Okay, so that is the mass of the sun we are talking, and the distance between the sun and the earth will be, if you can take in steps of astronomical unit, one astronomical unit, which is 1.5 into 10 power 11 meters, that is approximately 150 million kilometers. Can you imagine this magnitude of this big number? It's huge. Then when we talk about time, we talk in steps of our rotation of the earth, which can be 24 hours. So you can see 10 seconds, 10 power minus, then we went to hours. So this is a big world, this is a small world, and this is the classical world which we live in. This is the language we use when we are doing measurements in classical mechanics. So let's not waste any of the time, and let's dive into the world of classical mechanics. So let's dive into classical mechanics. Classical mechanics. So when we talk about classical mechanics, we talk in steps of constraint forces. Let's begin our discussion on constraints. What exactly does this word constraint mean? What is the English meaning of it? It is basically means limitation. Constraint basically means limitation, right? So when we have a limitation to the path of motion, limitation to the path of motion, then we can call it as a constraint, right? So if I have to say an object is said to be under constraint if it satisfies certain equations or inequality, it has to, in order to call something as a constraint motion force, it has to satisfy certain equations or inequalities. So what type of equations? Example, if I have to take an example of x square plus y square is equal to 25, this could be having a constraint between -4 to +4. So you can say a constraint force is basically arising due to the inequalities in the equations. So that's how we can say a certain we can also say it can satisfy certain equations. So it can either satisfy certain equation, satisfy certain equations, say, let us say this is a certain equation, certain inequalities it can satisfy. So then you call such kind of an situation as a as something is under a constraint. Something is under a constraint. Okay, so that's just the basic meaning of constraints. So what are the properties of these constraints? Let us look at the properties of a constraint force. Constraint force. What are the properties of constraint forces? So when we talk about constraint forces, it is basically, it is an elastic force, just like your rubber band. It is an elastic force. Then it is a strong force. It's a very strong force. So it also satisfies constraint. It satisfies constraint relations all the time. So when I talk about constraint relations, we are talking about the inequalities and all the certain equations which falls under constraint forces all the time. All right, so now this is what is constraint force. Now this is the properties of constraint force. Now let us classify this constraint force. Now let us look at the classification of constraint forces. Constraint forces. How do we classify these constraint forces? So let us start. There are different types. So let's start with scleronomic type. Okay, scleronomic. What does this scleronomic classification tells us? Scleronomic. So when we talk about scleronomic, what is the condition? So this is the type. Let us write the type in this column, and let us write the condition in the other column, right? So when we talk about scleronomic, so it is explicitly independent of time. Explicitly independent of time. Okay, so what would be the example of this? So example of scleronomic will be simple pendulum with constant length. Okay, so when we talk, it is not dependent on time. Simple pendulum length is not dependent on time. Simple example, simple pendulum with constant length, not variable, with constant. So if the length is constant, time can't do anything with it, right? Very simple. Then we talk about rheonomic. So when we talk about rheonomic, it is explicitly dependent on time. Explicitly dependent on time. Explicitly dependent on time. Explicitly dependent on time. So what would be the example of such a system, rheonomic system? So simple pendulum with variable length. Simple We can take the same example of simple pendulum and make its length vary with variable length. So how can we write as a function of time? If this is a position with respect to time, it will be a square of t. So this is how we write the condition. Then the third type is halonomic constraint. What do you mean by halonomic constraint? It is independent of velocity. Independent of velocity. So we spoke about time initially. Now we are talking with respect to velocity. Independent of velocity. So we can take the same example, simple pendulum of constant length. Let me call this as EG1, example 1. So here example will be same as EG1, simple pendulum of constant length. Then we talk about non-halonomic. So what do you mean by non-halonomic, halonomic, non-halonomic? So when we talk about independent, this will be dependent on velocity, obviously, as the name suggests, dependent of velocity. So you can take example as we can say rolling without rolling. Sorry, let me rewrite this. Rolling. Array yaar, my pen is kind of stuck. Let me erase this neatly. Okay, let me erase this part which was not looking neat. Now it looks neat. Rolling without sliding spear. Rolling without sliding spear. That's non-halonomic. You can call both of this come under with respect to time, so type 1, and we can call this as type 2, as they both come under the classification with respect to velocity. This both comes under time and this both comes under velocity. And we have still more classifications to continue. We have conservative and non-conservative. So conservative is basically when the condition will be where total mechanical energy is conserved, as the word conserved. It is conserved, does not change with respect to time, and no external work is done by constant force. So delta W will be equal to 0. You know, conservative and non-conservative forces. Conservative where work done by a closed loop will be 0, or no external work done by constant force. So example will be the same thing. Example will be same as EG1, which will be simple pendulum with constant length. Then when we talk about the next one, it will be non-conservative. We will go with the next topic, which is non-conservative type. So, or another way is conservative, non-conservative you can call, or it would be dissipative form. Okay, dissipative will be the right word. So it will be opposite to conservative. So total mechanical sorry, let me use my eraser. Total mechanical energy is not conserved. That means external work is done. And example will be simple pendulum with variable length. Simple pendulum with variable length. Okay, simple pendulum with variable length. So this we can call it as type 3, where it is dependent on energy conservation. So this will be kind of type 3. Then we have one more form, bilateral and unilateral. So bilateral, where both forward and backward motions are possible. Okay, both forward and backward motions are seen in the equation form. Okay, you can see that in any equation format, right? So the example for this will be simple pendulum with constant length, Eg1. Okay, then we have unilateral. No forward motion is possible. No forward motion is possible, right? So this is in equality form, and this will be in equality format, right? So for an example for an unilateral, so this is with respect to type 4 is with respect to the motion. So these are the four types. So the example for this will be spherical container of a fixed radius filled with gas. This could be an example. So these are the four types of constraints. And how do we, let us take an example. So now we understood what is constraints and the four types of classification of constraints, properties of constraints, all these things we have studied. Now let us do an example. Okay, example problem on constraint. Example of constraint. So let us do a classic example of a rigid body. How do you find constraints on rigid body? So rigid body, let us draw a kind of a rigid body. So let us take 2 points. Let us call this as Ri and let us call this as Rj. Okay, so from this we know the rigid body equation, modulus of Ri minus Rj will be equal to a constant. Okay, so let us see whether all the four types are there, type 1. So whether it is chloronomic or rheonomic. So does it depend on time? No, it does not depend on time. So which is the one which does not depend on time? The one which is independent of time is scleronomic. So the rigid body is scleronomic. Then let us look at the type 2 part of the rigid body. Does it depend on velocity? Do you see any differentiation with respect to time? Velocity is rate of change. So if it does not depend on time, it is obviously does not depend on velocity, because there is no time means you can't measure velocity. Does not depend on velocity. So it is halonomic or non-halonomic? It is halonomic. Halonomic means does not depend on time, whereas non-halonomic means dependent on time. So third type. So does it have inequality? No, it is having equation. This is in equation form. This has equation form. So if it is in type 3, it will be bilateral. bilateral. Then whether it is conservative or non-conservative. Work done, rate of change of work done. So in order to find type 4, the change in work done, so here the energy will be conserved, so the change in work done will be equal to 0, so it will be conservative. So it is scleronomic, halonomic, bilateral and conservative. So this is how you solve a problem with respect to any systems. So we took the example of rigid body. We can even do for example, let us say simple pendulum. Let us look at an example of simple pendulum. So simple pendulum, let us take an example of it. So let us draw the simple pendulum, okay, where we define this as the length L. So mod of r squared will be what? X squared plus y squared plus z squared is equal to L squared. So is it type 1? Is it independent or dependent on time? Independent of time. So it is scleronomic. It is scleronomic. Is it halonomic or non-halonomic? Independent or dependent of velocity? If it is scleronomic, it is obviously halonomic because it is both are independent of time and velocity. If you see scleronomic, you can just simply say halonomic because both are, if this is not dependent on time, velocity, obviously. So type 3, it has an equation, so it is in equation form, right? If it is in equation form, so you call it as bilateral. Both, you can also see forward and backward motions are possible with this. And fourth one, work done. So here what will be the change in work done? So if I say force into displacement delta r, so if I can put, if the change in position, if it is at rest, then the change in work done will be 0. So it will be, it can be conservative. So it is conservative, bilateral, halonomic and scleronomic. So these are some of the couple of problems, the way you can get it in example. You can do it with variable length, spherical gas container, rolling without sliding of a sphere. All these things we can do as homework and or assignment. If you want me to solve it, please leave a comment below. So guys, I'll be teaching you all these things, so this will be helpful for all. So who will benefit from this kind of classes? So people who are preparing for NET exam, GATE exam, IIT JAM, and then we have GRE physics. So all these students falling under physics category will benefit from this course. So I'll be doing a series of lectures like this. So if you like it, if you want more, you know what to do. Kindly hit that subscribe button, press a like button, share it with as many friends as possible, so many people can benefit. It is just sharing gyan, so try to spread it. It's a good thing to do. So we will meet. I hope you like the class and I hope you understood. If you have any doubts, you can always and also please make sure you read the description. Whenever I want to say something or leave something out of the video or anything, please I'll update the description accordingly. So keep reading the description below and make sure you follow me on other social medias as well. You can message me in Telegram as well, so I'll be happy. You can DM me on Instagram, you can message me in Telegram groups. I'll be leaving a Telegram group link soon in the description. You can join the group for studying GRE, all this GATE exam, IIT JAM, all the physics category exams. I hope you guys are working hard and trying to crack this exam. So I know how important this to you guys. I have gone through that phase, so we will make sure we will do it together. And yeah, if you want my face video, you can leave that message as well in the comment, so you can ask me whatever you want, so that we can have fun and keep learning until we crack the required exams. Okay, see you in the next class. Have a fun day, and yeah, see you in the next video. Take care. Bye bye.